so that you can find out what that would then mean down there. So it tells us that we have 14 of these piles. It also tells us that the piles are 7 meter 800 long, and that the pile cap at the top is 1200 by 1200 by 600 millimeters deep. So we need to understand that when we now start measuring this, which I will upload, which I will also upload now.
Kodwa at least indenza ndibe fresh leyo droga because ndiye ndihlambe after long. I think yona indenza ndibe fresh because
Excuse me, sir.
Yes, Mr. Madola.
Is the pile cap square or rectangular or circular?
Mr. Madola, you can see there, it gives us 1200 by 1200.
Okay.
So what does that mean? That means that it is square. Yeah, but this is because we would only have, if I can draw this from the top, you'd have the pile cap there, you'd have the pile sitting at the bottom of that. This is not, I should have drawn that dotted line, but that is what, 1200 by 1200 with the pile sitting underneath there.
Sir, do you ever have the pile cap circular?
Not necessarily, Mr. Madolo. The pile caps would come square, rectangular, pentagon shape, octagon shape, hectagon shape, different shape, but I've not come across circular pile caps.
Thank you, sir.
Okay. Right. When I now upload, I'm going to take this down and then upload the workings for does my screen show? Oh, I've not pushed the upload. Can you see my screen? Can you see my screen with the Excel spreadsheet indicated?
No, sir.
Not. We're back to that again. Okay, so I will try something different. Okay, let's try this one. Now. Take it you can see my screen now.
Yes, we can.
Okay, right. Now, you've seen the drawing. I've gone through that and I've shown you. I'll just jump. It should show both. You can see my drawing now. Change over to the drawing. Okay, if you can see the drawing, it says to us that we have 14 piles. That's a number that we need to measure. So meaning 14, everything that we'd measure in this drawing would therefore be 14. So when I go to my, you then start out and say that the following in 14 augered cast in situ reinforced concrete piles. We indicate that how many there are. That all is in line with the standard system. That tells that we need to say how many we have that we need to cast in that. So it says that we need 14 and allow for the establishment of plant, etc., on site for the piling operations, and allow for the subsequent establishment of plant, etc., on site for the testing of the piles. Now, what does it tell me? If I go back to my drawing tells me allow for the testing of any 3 piles. I don't know, it's not slightly different. I cannot use that and. Can we please just ensure that we are all muted? Okay, so when we have to test all the piles, we can then. So what I've picked up here now is a flaw in the sense that there says allow for establishment of plant for the testing. But the testing in this instance, the drawing tells me how many should we test. Only 3. The drawing tells me so this section here would now not form part of that, and we would have a separate description here saying that allow for the establishment of plant on site for the testing of the piles, and we will then have, but that then says that we need to only test 3 of them. Okay, so for the establishment of the site, for the plant establishment, that's for the 14, and then therefore, but this would not form part of that because it will form part of the separate, whereby I would say that we only test 3 of them. When I look at my standard system, tells me that on page 20, clause 4 says the setting up the plant at each pile other than the sheet number would then be number, but clause 3 says that the subsequent establishment of plant, etc., for testing is measured in item, and I will therefore have to indicate that I only need to do the testing of 3 of those piles in this instance. Allow for setting up of plant at each pile position. Now, setting up clause 4 on page 20 in the standard system says, and guys, the thing with piles is it's so easy because everything you follow what the standard system says, and you just need to then, therefore, at this stage, substitute the quantities or the lengths that we need to determine in this regard. So the setting up, it says on clause 4 on page 20, it said the setting up plant at each pile other than sheet pile will be measured in number. So now it's easy. We say allow for the setting up of plant at each pile position. It's measured in number, and we have 14 of those as per the legend that we had received. Now, I'm not sure whether we know what auger is. Excuse me. Auger is when we have a drill bit, the shape of the drill bit is in the shape of an auger, and so that when we drill, that anything that is drilled out will then find its way, auger its way up to the top. Or if we're drilling into timber horizontally, vertically, or at an angle, whatever is drilled into the waste would therefore, as the auger goes through, it would then be drawn out to the top. So auger in pickable material. And if you have a look at that schematic video that I'd shown earlier, it showed that as we drill, the rubbish comes out. The deeper we go, the shape of the drill bit is in such that it draws the waste material out of there. So we now need to auger in pickable material for 600 millimeter diameter piles not exceeding 10 meters deep. So when we now do this, and when we look at the piles, I want to take us a little further, and I want to go and have a look at what the standard system says about this particular excavation in the form of a pile. Now, when we deal with this, it tells us we would be working in sections of not exceeding 10 meter, and we then exceed them like 10 meter, not exceeding then in intervals of 10 meter for the excavation for piles. So when we go into this, and we then excavate and say that this does not exceed 10 meters deep, we have our depth. Where do we find the depth? We find our depth on my drawing, the drawing that indicated to me that the depth of my pile from the top, from my reduced ground level, all the way to the bottom gives me a length, which is L, and that is 7 meter 800. So 7 meter 800 to do that. And we measure these by virtue of us indicating that the piles are giving the diameter of the piles and also what the category is. We would therefore drill them, as we say on page 22. It says that auger piles drilling would then be measured. Clause 12 says to us that drilling separate into groups not exceeding 10 meters deep and thereafter in successive depths of 5 meters. So it will be not exceeding 10, exceeding 10, not exceeding 15, exceeding 15, not exceeding 20, and so we would go forth for the augered piles. So in drilling, in our description, we then therefore say that auger in pickable material for 600 millimeter diameter pile not exceeding 10 meters deep, and we have the length, which is 7.8, and we have 14 of those. Okay? Now at the bottom, as I indicated earlier, we would now have to expand the foot of this pile. And we say extra over augering for 600 millimeter diameter pile for under reaming for an enlarged foot 900 millimeter in diameter. And that we can see over there. It goes wider, it's 900, D there tells me it's 900, and the small diameter is given as 600. So we now need to measure, remember that we've measured this down there, we've excavated down there. So we now need to allow for that section there to be broadened. And we measure that as extra over augering for 600 millimeter diameter pile for the under reaming for the enlarged foot 900 millimeter diameter. And that is measured in number as per clause 12, subsection 21 on page 22. Under reaming for an enlarged foot shall be given as extra over drilling and measured in number. That's according to the standard system. We need to measure our concrete. Oh, but how do you measure concrete in number? 30 millimeter diameter reinforced concrete in 600 millimeter diameter piles. And now it says to us that concrete would be measured through the enlarged feet. That's on subclause 24. On page 22, it says that concrete will be measured in meter and measured through the enlarged feet. So when we measure the concrete that, we will not now be specific with being pedantic with how we measure. We would measure through that and we measure in meters because we've already indicated that it has enlarged feet. But we do indicate that separately by saying that the additional concrete 30 MPa in enlarged feet, 900 millimeter diameter for 600 millimeter diameter pile, and we measure those in number. Subclause 25 in the standard system tells us that additional concrete in the enlarged feet is measured in number. What have I done with my standard system, electronic standard system? Let's see that here. Okay, but that is on. Should maybe just upload that so that everyone can follow what it is where I am. Is my standard system shown here?
Yebo.
Yes, sir.
Okay. So this is on page 22. This is what I've now been measuring. Measuring the auger of the piles in the various lengths, the underreaming for the feet of the piles, looking at the concrete that goes in there, and also the additional concrete that it says is measured in number. And when I go through and I have a look at how I measured that, the additional concrete, it's measured in number, I'm indicated, and it's important that we indicate the size of the feet, the size of the pile, and just the number, how many are needed in there. The next item refers to the stripping back of the head of the pile cap, of the pile. When I look at my drawing, stripping back, you'd notice that the pile cap sits, and you see that the 600 is indicated over there, but the pile cap, and if you have a look at the different levels, 99,600 versus 99,400, it tells me that this pile cap is placed 400 millimeters below the reduced ground level, as pile cap depth is given to us as 600. So I now need to measure the stripping back of this pile. That now I need to measure. So that height there would be 400. And I now need to indicate that. And we indicate that strip back the head of the 600 millimeter diameter concrete pile for a length of 400 to expose the reinforcement. Now, why do you think we need to expose the reinforcement? Why do you think we need to expose the reinforcement? Anyone want to indicate why they think that the reinforcement need to be exposed?
I think for you to be able to tie in, if you need to extend your reinforcement, maybe for the pile cap, if you need to tie in into the pile reinforcement.
Absolutely, Madolo. That is absolutely correct. Because we know and we've learned through our previous 3 years of study that no bond is formed unless we have a bond with the steel wood that's in there and the steel structure that goes over that. And now this steel structure that goes over the structure that goes over this pile cap would be a reinforced concrete pile cap that would go in there. That would also have its own cage. We also note that on the top of this pile, that would be smooth. Why is that? For reasons that with all the movement that takes place in the ground here, you do not want the structure on top of this to be bonded to that, and you want the movement there so that the structure on top can actually move or remain stable when everything below moves. So you'll have a shear joint, a construction joint over there, what you call a shear joint. You guys know that deal with these. So we would now therefore strip back the top of the head of the pile for a length of 400 to expose the reinforced concrete. Now we measure for the testing of the piles. Testing of the piles or the 600 millimeter diameter piles, and we see that we were told that we only need to test 3 of those piles. Of course, the engineer will indicate. The contractor would not be asked to do that on his or her own, but the engineer will indicate which ones they want tested as in order for it to indicate exactly how that should be brought about. Now, something that I now missed out on. Okay. When I look at my next item, my next item that I measured now would be extra over augering and under reaming for piles and carting away the surplus excavated material. We now need to determine what the volume of that material is that we need to cart away. We need to determine what the volume is, how much of that do we really have to now indicate in there. This is where I wish I had my pen, my device already where I could show this now. I'll have to try and draw this with a mouse. Okay, if we go and we now look at my pile, I now need to, if I can make it clear, I now need to look at what that volume of that material is that I need to take out here. If I go in and I have a look at my shape, what shape do I see? The pile is cylindrical, right? And what shape do I have at the bottom here? What shape do I have at the bottom there?
Frustrum.
Because?
I was saying a circular frustrum, sir.
A partial circular frustum. Yeah? It's a partial circular frustum. Now, if we look at the dimensions, now I'm gonna throw the cat among the pigeons here. If you have a look at this, you see here that first and foremost we measured the cylinder. We've used the radius of 300 by 300 by the length of the pile, 7 meter 800, and it's times pi times 14, which makes sense because that is the volume of a cylinder. Okay. Then we look at the next one. The next one has a dimension of 2.2. Now, where on earth do we get 2.2 from? What is 2.2? I now need to determine what that 2.2 is. I need to measure the circumference of this foot. I need to measure the circumference of this foot. But from there to there, what do we have? 900. As the diameter there is at 900. Huh? So if we have a look at that, it is at 900. But so in order for me to determine that is there, what do I have? If I could draw this and try and draw a circle, which is not the best, and I have my pile on the inside. Remember, I've already measured that. I now need to measure everything around there. How do I measure that? The one thing that I can do, because I've already measured there, I now need to measure everything on the outside. And you've learned in third year structures that in order to find the center line of this, we need to work a third from the base. Is that correct? Third from the base. So if this is 600, then it tells me that that is 150 and that is 150. Do you agree with me? Because overall my large diameter is 900. Okay? So in order for me to determine what that length is, I will have to say 150. A third of 150 gives me 50. Do you agree with me? That's quiet now. Third of 150 is 50. So I will then have to indicate that from the center here, to a third of 150. It will therefore be my 300 plus 50 and that gives me 350. That gives me 350. So the 350 is from where you can see my cursor now to the center point of my extra section, of my ream section. And that will mean that in order for me to determine the circumference, it will be the circumference from there to there. I know I might not make lots of sense, but it will be the circumference that we will have not of the outside, but the circumference of 50 millimeter into my ream section. That's the circumference that I need to determine. So, if I have the 300 plus the 50 millimeter of what I had now learned working from the base of my cross-sectional properties in structure, then this instance will be 150, a third of 150 plus the 300. I can then work with that and I say that it is then the circumference is then 2 times pi times the new radius that I've now determined of 350, and that will then therefore give me, if you can calculate that, it should give you 2.1991. So that in essence gives me 2.2 meters of a circumference. I need questions now. Do we have questions? Or are we okay with what I've just said? Everybody good with what I've just said?
Could you please repeat it? Hear you clearly.
Could not hear me clearly. Okay. Right. I'm saying that. Which section must I repeat?
I heard you up until where you got the 350. After that, I didn't hear anything.
Okay, Nomta, you said you heard me after I got this 350 here. Right.
Yes.
Okay, now that 350, I'll say again, take me from the center to 50 millimeter into my section, my ream section. Now I need to determine, yes?
Can you please just move a bit below that, where you get this 51 first, a bit lost.
Where I get the?
51.
No, that's not 51, that should be 50.
50. Yeah, can you please just elaborate there?
Okay. What I'm saying is, if we have a look at that there is the reams, is this section here that's enlarged. Okay? And that there is 150. Right? And when we deal with known structures, if we need to determine the circumference of that section, because this goes all the way around, I will have to now work to a third of the base. And a third of 150 is 50. Third of 150 is 50. So it will be the 300, which is my normal radius, plus the 50, which is a third into this ream section, and then I now need to determine the circumference of that you can see where you can see my cursor. Now I need to determine that circumference because that will give me the center. And when I have a triangular shape, that tells me that I work a third for the center line of that. It's a third of my base, and that is a third of that, and that gives me the 350. And my formula would then be 2 pi radius And that radius is therefore the 350 millimeter that I have determined. And that then gives me 2.199. And because I work in 2 decimals only, that means it is 2.20. And that's going a long way in getting to that. And that will then give me what I need to determine. And if I look at the 2.2 multiplied by 0.15, and I have there multiplied by 0.26. Now, how on earth do I get to the 0.26? How do I get to the 0.26? I'm just going to clear up some stuff here again. I get to the 0.26. I know that this is 60 degrees. It's given to me there, 60 degrees. I know that this is 150. So if I work with the tan of 60, the tan of 60 equals, my tan of 60 gives me my opposite over my adjacent. So I'm just going to go and I'm going to do this, and I say that the tan of 60 equals my opposite over 150. Now, what does my opposite then determine? Well, what does it come to? If you will use that, you say 150 tan 60 equals the opposite, and that then gives me a length of 260 millimeters. Do you agree with that? Have you calculated that? So, I take it the silence means that we are with me. So, if you do that, it means that in order for me to calculate all of this all the way around, I will then use the 2.2 multiplied by 0.15 multiplied by my height, which is 260, multiplied by 14 times half, because my shape there is triangular. Okay, all good.
Sorted.
Okay. Now I want to show something else. I want to literally throw the cat among the pigeons and just try something else out, and let us see whether this would work if we do that. You all remember the prismoidal formula? You remember the prismoidal formula? That says h over 6 multiplied by the large area plus the small area plus 4 times the middle area. You remember that one?
Yes.
I think I still taught you that formula in first year, if memory serves me correct. Now,
we are talking not from the same institution, we from another institution.
It doesn't matter. You would have done the prismoidal formula in there too if you were at Walter Sisulu. You would have done that with Mr. Elliott. So yes, you would have done that the prismoidal formula, whereby especially used where we deal with bulk excavations. Can you remember that? Do you not remember that?
Yes.
Yeah. So. See, fortunately, I know because I am a moderator for Walter Sisulu University, so I know a little bit about that. Right. So when we look at this is what I want to do. We've now determined that height there is, how much is that height? 260, right? We know that the height from there to the bottom is 7 meter 800. And I want to say to you, I want to cut that off there. And I want to, over here, instead of saying 0.3 by 0.3 by 7.9, I want to say over there, I want to say I want to just write something here quickly, and I want to say to you that I say 800 minus 260, and that gives me, what does that give me? 800 minus 260, that then gives me 7540 millimeters. And I will explain what I'm doing. I'm taking the length from there to there. And I say that that length is there is then, I'll then say that L is therefore equal to 7540. Right. I'm saying that L is 7540. What shape am I leaving myself with here? Leaving myself there with a trapezoidal shape. And then I say to you that I would therefore then say my height divided by 6, and I would then large a plus small a. I use that formula. Do you still remember that formula?
Yes, sir.
Okay. So I say that instead of going through what I've just done to determine that and to determine all that, we can also use this. And then instead of, when I then come to this here, I then say over here that I then say 0.3 0.3 7.54, and all of that. Remember, guys, I'm not just doing. That will then be 14 times pi. And I would then here. I'm just trying something else here.
So about that.
Okay. That now is my one. I've now deducted that. And then I can go in and I can then go and say here, over here, and I go and I say 0.45, 0.45, 0.26, and all of that is multiplied by 14 multiplied 1/6. Remember this here is 1/6. It's not 1 times 6. It's 1/6. And I have that there. That's my large area. And then can continue Then can continue by saying 0.3, 0.3, 0.26, it will be 14 times 1 over 6 times that. That's for my top area. Because I'm going with my formula that I had inserted over here of h over 6 multiply large A plus small a plus 4 times my middle area. Now go back to this. The next one here would then be the average of that, which would then be 300 plus 450 and all of that divided by 2, that gives me, what does that give me? Because I'm not using, or I could say 600 plus 900 gives me 1.5 divided by 2 gives me 750, and the average of 750 divided by 2 gives me 375 millimeters. The 375 millimeters. So then here, I can then say down here, 0.38, 0.38, 0.38, 0.26. And I would have, here I would have 14 times 4. This is now divided by 6 again, guys. That is very important. Times, get this, I like this. So that, now this will be 4 divided by 6, your formula. And if you then go and you square all of this, you should effectively get the volume over there. I'm not sure whether you have done that squaring there, and whether you received that. Just as a test, you can do that, but just to show that instead of working with all of this here, all of that there, that you can, by creating a trapezoidal shape there and having your cylinder at the top, you can, and it's something that you guys, I would suppose, are a bit more familiar with. I'm not sure. You guys need to tell me, do you prefer the first method, or would you be okay working with this method that I have just shown over here? Now possibly is a good time to speak about that, to determine which one would work for you.
First method, sir.
You prefer the first method? No, that's great.
Yes.
You work with whichever one would be good for you. If you were good in using the trapezoidal formula, then this one should work for you. Yeah, it should work for you. And I'm just going to do a quick calculation to see whether this should actually work. Right? I get 30.37 cubic meters if I do it with the trapezoidal shape. And if I do the other one, I get 31.47 cubic meters. Now that is a difference of, actually when I calculated yesterday, I got 31.39 cubic meters. I might have had happy fingers or fat fingers there. But whichever one you use, you would not be incorrect, because all you're doing is remember, you're turning this into standard shapes. And these are some of the standard shapes that we have used when we measured in our first year. All of us, no matter where we were, whether we were on a BSc in construction economics, or whether we were at a national diploma in building at TUT or Walter Sisulu or Nelson Mandela or CPUT, whichever, because that is the basics on which we would be working from. Now, I just thought that I would show that just to indicate to you that there is a different way in which you can now go about and doing that. Okay. So next now, I now need to measure my 12 millimeter diameter mild steel reinforcement in my piles. And when I look at the steel reinforcement tells us in the standard system, it actually tells us in the standard system under piling, it says that the steel reinforcement shall be given in accordance with the principles laid down in concrete formwork and reinforcement. So I'll just go to there. It tells me that a steel reinforcement shall be given to us in accordance with the principles laid down in concrete formwork and reinforcement. So when we go to concrete formwork and reinforcement, and we look at the reinforcement says on page 30, reinforcement, it says that under general, reinforcement shall be classified according to the quality. Then it tells us further on, bending, hooked ends, and binding wire, cover blocks, and spaces in accordance with the relevant SABS codes of practice and maintaining the position during concreting. And that means it shall be deemed to be included in my description. That no separation of reinforcement shall be made for different concrete components. Indented or any other deformed reinforcement shall be given separately. Curved reinforcement shall be given separately. Helical reinforcement shall be given separately. Reinforcement in sliding or climbing formwork shall be given separately. Reinforcement to galvanized or otherwise treated shall be given separately. Reinforcement shall be measured to the design lengths. Calculation of masses shall be based on the values shown in the relevant structural steel tables issued by the South African Institute of Steel Construction. And no allowance in the mass shall be made for rolling margin. So what this means is that we will be measuring this steel reinforcement separately. So the steel reinforcement will be measured in tons. It will be measured in tons. And now what do we do? So it says different diameters shall be given separately. Bars in lengths exceeding 30 meters and not exceeding 18 meters shall be given separately, thereafter in stages of 1 meter. So what does that mean? It means that we would start out by saying measuring our steel reinforcement up to 13 meters, not exceeding 13 meters, and thereafter we would say exceeding 13, not exceeding 18, and thereafter exceeding 18, not exceeding 19. That is our increments of 1 meter after 18 meters. So when I measure my reinforcement, I was told that the diameter of my reinforcement is 12. It's 12 millimeter diameter. The spiral is 10 millimeter. I've been told that the length is 7 meter 800. So I will therefore go through and I'll say 12 millimeter diameter valve steel reinforcement in piles not exceeding 13 meters long, because I was told that it is 7.8 meters. The drawing tells me that, and because it is measured in tons, I will write down my length thereof is 8 in each pile, and I have 14 piles. Whatever that value is over here would then be multiplied by the weight per meter, and the tonnage would then therefore be transferred to my bills of quantities or my abstract form, which I would use first. So it's a 12 millimeter diameter, mild steel, not exceeding 13 meters long. I have 7.8 meters as per my legend, and I have 8 per pile, and I have 14 piles. My next one deals with the 10 millimeter diameter mild steel spiral or helical reinforcement in piles. Now I'm going to go to my standard system. It says that curve reinforcement and helical reinforcement shall be given separately. And I know that this is spiral, and we've done a spiral in our first year. We've done a spiral in our first year, and in the spiral we indicated that when we measure a spiral, that we now need to determine the length of the spiral, and the formula for the length of a spiral, it says that, I'll write that down here, is that L, which is the length, equal to and now I need to find the square root. Where do I find the square root sign? How do I indicate the square root sign? Oh, I cannot see where to find the square root sign on. Where are the fundis of working with PDF? If this was in Excel, I'd be able to do that. Anyway, I have the square root. I'm just going to put this there. The square root of what? Of c squared.
Yeah.
I can't do this here, man. I need e squared plus p squared and all of that is multiplied by the number of p's. Do you remember that? You remember that? I can't remember. The number of p's. So, what do we use this? How do we use that? We need to determine L. And now we are given that L is that, we are given L as 65.8 to 86, but how do I get to that? When I substitute this here, C equals the diameter. or the circumference, and that will therefore be pi times the circumference. My circumference is 600 minus 2 times 60. What is 60? Can anybody tell me what they think 60 is? When I say that C equals pi times my diameter. They're not pixels. Let me draw the equals pi times my diameter. And what is my diameter? My diameter is equal to 100 minus 2 times 60. What is that 60? It's the cover. Do you understand? You know what the cover is? That then gives me 480 millimeters. Now what does that mean? It means that the diameter for my steel, even though my diameter is 600, my steel cannot be placed at the 600 diameter. Does it make sense? Why can it not be placed there? It cannot be placed there because once that steel is exposed to the moisture in the ground, what will happen to that steel?
Rust.
It will rust. So what does that mean? It means that we need to have cover in the form of spaces that we would have on there, and we'd work with in this instance, we would work with 60 millimeter cover, and you'd be told what the cover is that you need to have. So my diameter for my spiral would in this instance therefore then be 480 millimeters. Does that make sense? Does that make sense? Nobody talking to me. No hands. No questions. So I take it we are all on board. Take it we are all here. We are all happy with what it is that I'm saying. That's it. Okay, right, fine. So I have my cover, and I have taken my cover off. So my diameter now is 480 millimeter. So I can calculate this here by saying pi times my diameter. So I can say that my 480 and C would therefore be C would therefore be, and I'd need to have, it'll be C squared, so it'll be pi times my diameter and the square of that. Can you see that? I need a pen to write on this so I can show this to you. So if that is 480, it means that over here, the square root where C squared, it will be 0.48 multiplied by pi. So it will be, let me put this here. So that will be 0.48 multiplied by pi and the square root of that. That will be C. Okay, happy with that? So that goes in there. And then I have plus, what is P? What we were given P as 180 millimeter. There. It was given to us over there as 180 millimeter. So I go back and I say that plus 0.18 0.18, and I'm going to do, because I don't have the square root of that, and the square of that. And of course, we need to find, I don't want to add a dot, I need to, or a circle, I need to write. So we'll have to have the square root of that, and then that multiplied by and what are the number of p's? How many p's do we have? I will then therefore have to say 7.80 divide 0.18. Because that will give me the number of p's that I would then, and therefore, where is my highlighter now that I need? Guys, where can I find so the square, and then if I do this here, it's not that either. So the square root, and I'm just going to highlight that. You need to calculate that, and the square root of that, and that multiplies by the number of p's, and that should give you my 65.86. Do you get that if you work with me on the calculator? Silence. Silence.
So is it okay if I get 65.81?
That's fine. If you did you work through everything like that? That is fine. We will work with that. I will work with what you have and what you can show me.
Okay, thank you.
Okay. Yeah, I get 65.81. I've just calculated it now. I get 65.81. That is fine. Right? And you have 14 of those. And that is to determine the length of my spiral. But it also is important that we do not forget to indicate that all of this will be measured in tons. As per the standard system, that tells us that the steel will still be measured in tons. Over there tells me that my steel will be measured in tons. Okay. So as we make our way forward, and we now look at the pile caps. The pile cap, as I said, is a square. In this instance, it's a square object. It is it'll only have one pile placed under it. It's a square object, and we will have our pile cap. We'll have to excavate for the pile caps. And I'll go back to my drawing. We'll have to excavate for the pile cap, and in excavating for the pile cap, I will only be excavating there to there for the pile cap. We excavate in pickable material for my pile caps not exceeding 2 meters deep, below reduced level, and extra over excavation for carting away the surplus excavated material to a site plus minus 3 kilometers away or wherever that is. So we will now determine that we've had the size of my pile cap. It is 1200 by 1200. I was given that. 1200 by 1200. And my depth, I said, is 400 because the difference between 99,600 and 99,400 is 200, and my pile cap is 600 deep. So that will be by 400. So it will be 1.2 by 1.2 by 0.4, and I have 14 of them. And I'm doing a weird thing here. And I'll accept this. You guys are big now. You have your big shoes on now. I will now use the deduct in here. I will accept the deduct if you place that over there for me. But you need to still indicate that it's deduct. And I'm deducting the pile, and it's 0.3 by 0.3 by 0.4, the same depth times pi times 14. And that refers to that section over there that we have already excavated for. I do not have to over measure and place that section in there again. So I'm deducting that for the pile, and I keep my excavation free from water. I then also go and I say risk of collapse to sides of my pile caps not exceeding 1.5 meters deep from ground level. That is 4.8 by 0.4 times 14, or as is shown here, 1.4 by 0.4 by 4 by 14. My concrete, reinforced concrete in pile caps, partly cast against excavated faces. Why partly cast? Because part of this pile cap sits above the ground. Part of this pile cap would have formwork around it. That is why it's partly cast against excavated faces. That is 1.2 by 1.2 by 0.6 by 14 of. Remember, a very important note, there is no need for us to deduct the pile because we have already stripped back the pile cap to expose it in order for it to form part of the pile cap. We already stripped back the pile in order for it to form part of the pile cap, as Madolo said earlier, in order for that bond to be formed there. And then whatever the type of formwork is, in this instance we say smooth formwork to sides of pile caps, projecting above the ground level, not exceeding 300 millimeters high. When it does not exceed 300 millimeters high, we generally measure in meters as per the standard system. And in this it will be 1.2 by 4 by 14. And that, ladies and gentlemen, brings us to the end of that drawing RC008, which is the pile with a pile cap. I now need to take questions. Are there any questions that you guys would have for me on this pile? Piling is one of the easier sections. It just seems complicated with everything that we're doing there, but it is fairly straightforward. Are there any questions? Yes, Celindelia.
Could you please go back to that spiral reinforcement in piles? Where we got that 0.18 from? I missed that. Could you please elaborate?
Okay, the 0.18 there, it tells me that P is 180 millimeter.
Oh, okay, thanks. I missed that.
Got that? Okay, Ms. Maguvani. Okay, anyone else? Yeah, Nomta?
So, same question. The 2, is it square?
Which one is that, Nomta? I just need to...
Wait.
This here. This two over here. That two there in this institute is. Can you see my screen, Doctor?
Yes, I can, sir, but it's lagging, so I can't see where you're pointing at.
Okay, I've highlighted the two. I've highlighted the two here, over here. Can you see? Is the screen with you yet?
No, sir.
Okay.
Oh, yes, sir. That's
see that two there.
Yes.
It's a square. It's a square, yes. If you have a look at this over here, Nomta, the formula here shows it's the square root of c squared, and this is c squared. That is c squared. I did not have a place where I could show squared. I see that there are some other things here, but that is a square, and that is a square. Yeah.
Okay. Thank you. Yes. Thank you.
What I would do, I would also upload the a page with a formula for the calculation of the spiral. Okay. Any other questions? Any other questions, guys? No one? Right. If there are no questions, what I have done, I have also uploaded drawing RC 010 or 10. Right? I've skipped 9, but I've skipped 9 on purpose because I'll be uploading 9. Now 8 and 10 have all the workings out there already. I'll be uploading 9 without the workings out, and that you would have to, for yourself, would have to work out and determine how we go about doing that. 9 could be a nice tutorial, but that 9 would be for your own practice that you do. And I will not start with 10 because there was a lot to take in, and I will do 10 when we come back from our short recess. We'll do 10 then, but I've already uploaded 10, so you can go forth and you can work through 10 and see how all of that would work out for you. So it gives me next week so that I can finish the marking of the assessments, which I started on. When was the public holiday? I started on Tuesday. I started the marking on Tuesday, and I will want to complete it so that when I do see you, that it all would have been marked, and you would have your marks uploaded on the system moving forward. Are there any other questions, guys? Before we wrap up this class, I thought that I might be able to do 10 today as well, but I realized otherwise. Sandile?
Yes, sir. Whilst you still talking about the assessment, I wanted to query because some of us who registered late. I don't know what's going to happen to you. So I've tried to send an email, but seemingly, I don't know whether you've been busy.
Okay, no. Okay, Sandile. I was out of town the whole of last week, and we will be dealing. I just need for everybody that registered late and all that to communicate with me so that I can have a fair idea of who they are, what the numbers and all of those are, so that we can work on a plan on that.
Okay, thank you, sir.
Okay. Any other questions or comments that we might have? Just showing that I'm sitting at the office. I'd actually love for us to sit in a classroom where we can sit mask to mask, even if it's that. If I can have that, guys, I would do that at a drop of a hat. And our numbers are not that large, and we can actually do that. For those of us who are out of town, and maybe we can see how we can come in, how we can get here and to ensure that we could possibly do that. It would just help so much if we can do that. I know some of us are still out of town and that, but I would give everything for us to be here in person and to be able to sit and to communicate like that. Maybe you can drop a petition to me and tell me how many of you want to come, and then I can take it forward and we can then do that. I'm also even looking at live streaming where I could sit and be in class with people in class and I could lecture right on the board and do that. And that's also what I'd like to do. But I don't know whether I can get that right. But if you can tell me that you want to be here, I can take it forward and we can motivate for that. Okay. Yes. Have we determined who the class rep would be yet? Because I know you guys have got a group going on WhatsApp. No class rep yet. I've not gotten to a class group yet. Because you guys operate differently. You guys have ways of working undercover, underground, and all of that. You know how to find things. No one has put their name up, their hand up to be the class rep yet.
We do have a class rep for QS.
Who is that, Nomta? Maybe you'll tell me. I'm hoping you will tell me. Because the class rep hasn't communicated with me. Is it Zara?
Hi, sir. Sunday is the class rep.
Is Sunday the class rep?
Yes, sir.
So it's Saka Sunday is the class rep. Was that unanimously or democratically selected?
Five.
Is Sunday yet?
He or she elected themselves, and it was uncontested.
Oh, Sunday elected himself and it was uncontested. Okay. I will therefore then speak to the class rep and find out how come he had not, because I asked him, he said no, he had not, he was not selected, but I will do so. I will speak to him. Okay, so Sake Sunday is the class rep. No, that's great. Okay, guys, I'm gonna thank you for attending today. And thank you for attending today. And we can from this we will move forward. And I please need your comments. I need your comments on how you find this way of teaching, on how you find your understanding, particularly of this module. I shouldn't say that I'm not so concerned about the other modules, but particularly this one, which is not just theory, where we cannot just go and sit and go and read up and regurgitate the information. I need for you to tell me how you find this way of teaching and how and whether you feel that you would want to possibly come to campus and have mass-to-mass classes whereby, and then we can look at arranging for a venue big enough that where we can still ensure that social distancing takes place, but where we can also still communicate with each other in a professional manner and the like. But I need for you to communicate with me in this regard. Hopefully through the class rep, or if you feel you'd rather communicate with me directly, also do so. If there aren't any other questions or comments or anything like that, think about it. Enjoy your break next week. Don't forget about your school books and that. But enjoy your break, and we will see each other back in 2 weeks' time. Nomta?
Something completely unrelated. I'm aware that last day we were supposed to have training of some sort on candy. So I wanted to ask if the university will organize something for us this year. Maybe we can do it virtually.
That is one of the aspects that we are busy with, Nomta, as we speak. We know the importance of getting that so that our students can be prepared for moving out there, and also hence us having the we are between myself and Miss Emma, we are busy working on getting the guys from CCS Construction Computer Software to do a virtual presentation. And obviously, we are still busy working out what the cost implications and everything like that are. And those cost implications obviously would be borne by the student. But for we also do an online training with regards to FIDIC and NEC that I'm not sure whether Ms. Crystal van der Merwe had informed you guys of, and that the institution pays for that is for free. The institution pays between the three departments, we pay for that, and that should also still come up pretty shortly. That also is a 2-day course, if I'm not mistaken, whereby you'll be spoken to about FIDIC, NEC, and also to some extent the JBCC. But yes, Nomta, we are working on the CCS training that needs to take place. Anything else, guys?
Okay, thank you.
You're welcome. If nothing else, guys, I would like to thank you again for your participation. I'd love for you guys to ask me more questions. You guys need to understand something.